I'm Alicia. I'm a product manager here at Cockroach Labs, where I focus on building out our disaster recovery and our business continuity tooling. And today, we're really excited to be here to be able to speak to you about all of the innovative work that Cockroach Labs has been doing across resiliency, security, and AI. So let's get started. Take this clicker. All right, so before we fully dive into those topics, I want to quickly level set, take a step back, and see how databases have evolved over time. I'll start by zooming all the way back and by talking about the PC computing era of the 80s and the 90s. In this era, we know that traditional databases were built to support applications running on a single machine. And their job was really simple: store and retrieve data reliably. And Rob did a great job earlier at going through all of that. Then comes the mobile computing era of the 2010s and 2020s. As we all know, we saw an explosion in cloud and mobile apps. And in this era, scale and availability has truly become critical. And this is how we saw a rise of NoSQL and distributed SQL databases. And we know these types of databases can handle global workloads and massive user growth, as well as spiky workloads. So that brings us to today, where we're entering the AI integrated computing era of the 2020s and beyond. And so here, data isn't just powering apps, but it's actually powering intelligence and agentic workloads. And so that's where features like vector databases, along with distributed SQL, come in. And that's how we're really enabling AI-driven applications at scale. And so while the purpose of databases, which is to manage data, has remained largely the same, the way they function and operate has transformed dramatically with each era, as we can see. And so now, with CockroachDB distributed SQL, we know that we get the benefits of transactional consistency, along with the same scalability that you would get from NoSQL. And you get this all with a Postgres-compatible interface, along with vector support. And this is really what makes Cockroach ready to handle this new era of computing and beyond. And so CockroachDB is ready for this new era. But on top of our key differentiators around handling consistency, reliability, scalability, and AI readiness, we have a breadth of different deployment options, allowing you to choose what works best for you. So on one side of things, we have our self-hosted product, which offers you absolutely flexibility and control over how the database binary is deployed on your own architecture. On the other side of things, we have our managed offering, Cockroach Cloud, which handles all of the operational overhead for you. And so you're really getting a plug-and-play service, and you can get your application up and running quickly. But now we're introducing Bring Your Own Cloud, BYOC for short, so that you can get the best of both worlds. With BYOC, you're getting the managed aspect of Cockroach Cloud, easing your operational burden, and so you get the ease of using a managed service. But you're also getting the same flexibility from self-hosted. So you get control over your own infrastructure, and you can manage your price points and your total cost of ownership. We're really excited about this new offering, as well as continuing to build upon our existing offerings. And so if you're curious to learn more about any of these and figure out what's best for you, feel free to talk to any one of us after this session. So now hopefully that gave you a good sense of Cockroach's differentiators and how we offer you the flexibility to pick what works best for you, especially in this new era of databases. But now let's get back to the topics at hand. So today we're really excited to cover 3 core topics. The first is around cross-cluster replication in CockroachDB to handle 2DC workloads and ensure that you have resiliency and survivability that meets your business requirements. The second topic is about how CockroachDB is delivering security and trust for your applications at scale. And finally, we'll be talking about how CockroachDB is architected to handle AI workloads, again, for this new era and beyond. So I'll start by talking about CockroachDB's cross-cluster replication tools. And that brings us a lot deeper into this theme of resiliency. Now, as we know today, and this is going back to a little bit of what Rob talked about, we know that today CockroachDB enables resilient, fully consistent clusters. You'll see here that I have a diagram of a multi-region cluster. This cluster is running across 3 regions in the US. So we have a region in the West, a region in the East, 2 regions in the East, actually. We know that this cluster, with CockroachDB and just how it works today, this cluster can handle critical distributed workloads. And we also know that this cluster can tolerate region outages. So for example, if the west region goes down and we have an outage, this cluster can stay up and running. The other two regions in the east can handle the application traffic with no downtime. Now, all of these powerful differentiators and resiliency is powered through our native RAF replication within a cluster. Again, we know that RAF replication is powerful today on its own. It enables full data consistency between nodes, zones, and regions, and there's also zero data loss and downtime during failures within a cluster. So, on its own, CockroachDB RAF replication is already very powerful. But we also know that some customers have other requirements. We know that one really common requirement is around being able to be deployed on just 2 data centers or 2 regions. I see this a lot when I talk to our customers in India and in APAC who are limited to just 2 regions due to the CSP providers. I also see this with customers who have built their application logic off of 2 data center topologies, and they don't necessarily want to migrate to have their application logic support multiple regions at the time. They don't have the bandwidth. And despite that, these customers want to be able to survive a region failure while running CockroachDB on 2 regions. We also see some other requirements around latency. We see some customers not able to tolerate the multi-region latency, right? So they don't want to incur that network latency when we go across regions. They just want single region latency. We also see some customers that want to migrate data between clusters. They don't want to have their data leave the CockroachDB ecosystem while they're doing this, and they're looking for a seamless way to really replicate and migrate their data while they use their clusters for different use cases. And finally, we also have some customers that are just looking for some more flexible deployment topologies off of CockroachDB. And so that is where Cockroach's cross-cluster replication tooling comes in. So our cross-cluster replication tools are built on top of our native RAF replication layer, which, as I said, we already know is super powerful today. But these tools enhance that and are able to help us meet these new customer requirements. So today I'm going to be talking to you all about 2 tools here: physical cluster replication, or PCR for short, and logical data replication, or LDR for short. Now, both of these tools are now generally available. So after the session, if you're interested, you can try them out now and feel free to ask us any questions, check out the docs, etc. So let's first start by talking about what PCR is, why you might want to use it, and how it works under the hood. Again, PCR was generally available starting in 24.1, so you can try it out today. And it's really exciting because we actually just released PCR in limited access on Cockroach Cloud. So if you want to spin up a cloud cluster and try it out, you can also feel free to reach out to us to try it. So let's start by talking about what PCR is. PCR enables an unidirectional asynchronous replication stream between CockroachDB clusters. You'll see here in my diagram, I have a source cluster, which is our primary cluster. This cluster is able to receive our production traffic at scale. Using PCR, this cluster is replicating data over to the standby cluster. And this cluster is able to receive business operation reads. So you can run select queries off the cluster, you can run your analytics queries, etc. And with PCR, you're able to fail over from the primary to the standby cluster if you want. If there's an issue or an outage on the primary cluster, you can quickly fail over to the standby, bring it online, and make it able to receive application traffic within a matter of minutes. And so this is how PCR really helps us create what is commonly known as an active-passive topology between CockroachDB clusters. And so you might be thinking, what are the common use cases for this active-passive topology? Really, why did we build it? What are the problems it's trying to solve? Well, the core use case for PCR and for active-passive topology is to survive region or cloud outages, especially with 2DC topologies. So again, you can use PCR to survive a region outage if you're running cluster A in one region and cluster B in the second region, and the first region goes down, you can quickly fail over to cluster B. And again, do this all with very little data loss and downtime. And so PCR is a really useful 2DC disaster recovery strategy. We also see customers using PCR for workload isolation. So because you can run analytics queries or read queries off the standby cluster, you can have PCR running and basically move some of these non-critical business functions to the standby cluster and really conserve resources on your primary cluster. And finally, another really common use case that customers use PCR for is for data migration. So you can use PCR to migrate data seamlessly between CockroachDB clusters. This is really useful if you're just really quickly trying to seed a dev cluster or a dev environment with production data. Or it's also useful for customers who are running blue-green deployments with upgrades, etc. And so these 3 use cases are, I would say, the most common for PCR today. So I've talked about the what of PCR. I've also talked about the why. I want to dive a little bit into more of the technical details and how PCR works under the hood. So one thing to call out about PCR is that it's happening at the cluster level. So with replication, we're unaware of any sort of table or row boundaries. We replicate all of the data in the cluster. And that's what really helps us make PCR be transactionally consistent. So at any given point in time, the standby cluster is transactionally consistent with the primary cluster. This is really awesome because, as we all know, consistency is one of our key differentiators for Cockroach Labs. And basically, this means that you can use PCR without having to compromise on consistency. So I've been talking about how PCR replicates at the cluster level. I've been talking about the high level, but I also want to talk about what things look like from a transaction point of view. You'll see here I have a diagram of essentially a life of a transaction in PCR. First, you'll see that the transaction has committed from the client, and now it's been committed onto the primary cluster. And once that transaction commits, PCR immediately starts replicating that data over to the standby cluster. Something I want to call out here is that means that we never replicate uncommitted data in PCR. We only replicate committed transactions. And so you might also imagine, and you'll see here in the replication lag, there's going to be some time from when that replication was first committed on the primary to when it lands and is replicated on the standby. We call that time difference the replication lag. The important thing to note here is we keep track of all of these timestamps that make the replication lag because we want to ensure that the standby is always a transactionally consistent copy of the primary cluster at any given point in time. This also means that we're able to account for all data during PCR. So you might imagine if you were to pause the job, we keep track of that timestamp so we can immediately start replicating again from where we left off when you resume the job. But PCR doesn't just replicate transactions. Again, just a reminder, it's replicating everything in the cluster. And so it also replicates DDL statements in that case. So if you're running a create table, if you're dropping a table, PCR will go ahead and replicate all of that. PCR also replicates schema changes. So if you're adding an index, dropping an index, adding a column, dropping a column, PCR replicates all of that with 0 additional operator intervention. So you don't need to do anything. PCR will replicate all of that automatically for you. And that's what makes PCR a really low operational overhead tool to use. And so I've been talking about how PCR can be used for disaster recovery, but I also wanted to get into the details of how PCR actually handles different types of disasters, maybe not just a region outage. So let's talk about it. Let's start by talking about the first type of disaster that customers commonly talk to me about, which is like a node outage or a network partition. In this case, PCR will natively continue trying to replan the node connections between clusters, and once the transient issue has been resolved, we'll just continue replication without any manual intervention required. Now, in the case of a cluster or a data center outage or something more severe, again, PCR has this built-in failover capability, and you can initiate a failover to the standby cluster and do this with very low RPO and RTO. But besides hardware and infrastructure outages, I also want to talk about logical issues. We also see this with our customers. No one wants to admit that they accidentally dropped a table, but it sometimes does happen, and we should all have a solution for when those accidents happen. This is where PCR has a really exciting feature where we allow you to fail over to a time in the past. So, for example, if I drop my table at 2 p.m., with PCR, I can fail over to 1:59 p.m., and I can basically get the state of the cluster prior to when I committed the logical issue. So this is really powerful because this allows PCR to almost act like a flashback tool. We can apply the same concept to cyber attacks or anything else that's sort of causing like data corruption issues, logical corruption on the primary cluster. Again, with PCR, you can fail over to a point in time prior to when this issue happened, making it a really powerful tool to quickly recover from these types of errors and disasters. All right, so I keep talking about how PCR is a disaster recovery tool. I know that we can't talk about DR without also talking about metrics. So as Rob said earlier, the two most critical metrics in disaster recovery is around our recovery point objective, which is measuring our data loss, and our recovery time objective, which is measuring our downtime. So we've benchmarked PCR at scale with hundreds of thousands of writes per second, and some of our largest customers are using PCR. With this, we see an average RPO of around 30 seconds. So that's basically captured in the replication lag. For our RTO, or our downtime, it's roughly 1 to 2 minutes, depending on the time it takes for you to cut over. So basically, RTO is the time it takes for us to fail over to that standby cluster and bring it online and able to receive application traffic. Altogether, this makes PCR a really compelling low RPO, low RTO DR tool, as well as for other use cases around workload isolation and data migration. And so I hope that gave you a good sense of what PCR is and why you would use it. But in the interest of time, I also want to make sure that we cover our other cross-cluster replication tool, which is logical data replication. I see LDR as PCR's sister tool. They have some similarities and they also have some differences, so I want to make sure we can get into that today. Again, LDR is also generally available. It's GA'd in 25.2, so if you're interested in trying it, you can feel free and try it, and we have docs on that, and we'll be available to answer any questions that you might have. So, unlike PCR, LDR enables asynchronous logical replication streams between clusters. The main difference here is that both clusters can receive application traffic. So you'll see here in this diagram, I have cluster A. I have one replication stream, which is replicating data from cluster A to cluster B. And then I have cluster B, where I have another LDR stream replicating data from B to A. And that's how we can create bidirectional replication in LDR. We'll also see here that both clusters are able to receive production reads and writes. So both clusters are actually benefiting from low single region latency writes. And because of this, we're able to create a highly available solution with 2 data centers. And this makes LDR basically what we consider to be an active-active topology with CockroachDB. Reminder that PCR is an active-passive topology, so that's kind of the key difference here. And so we said earlier that PCR replicates at the cluster level. LDR actually replicates at the table level. This actually gives you a lot more flexibility. If you don't want to replicate your entire source cluster, you can choose which tables you want to replicate instead. We know some customers have like thousands of tables on the primary cluster and they don't want to replicate all of them. LDR gives you that flexibility. And another common question I often get asked, especially with active-active topologies, is if both clusters can receive application reads and writes, how do we handle conflicts? What happens when writes are going to the same row? And that's where we built in last writer wins conflict resolution with LDR. We do this based off of the MVCC timestamp of the replicating write, so it's as accurate as making a write to our database directly. And all of this is handled natively within LDR for you, so you don't need to do anything with regard to conflict resolution. All of this put together makes LDR really useful for 2 use cases. The first is achieving high availability with 2 data centers, and the second is workload isolation and data migration. So let's talk about the first. So consider this topology that I have here. I have a cluster in Delhi, which is receiving traffic from north, and I have a cluster in Mumbai, which is receiving traffic from the south. Because I partitioned my application logic, my application traffic, I'm able to benefit from low single region reads and writes to each cluster. Now you'll see here that the 2 arrows here are representing the 2 LDR streams that I'm running between the clusters to achieve bidirectional replication. So basically, all of the south traffic is being replicated from Mumbai to Delhi, and all of the north traffic is being replicated from Delhi to Mumbai. If there's an outage, so for example, if Mumbai goes down, I can quickly redirect all of my south application traffic over to my Delhi cluster and do this all with very little data loss and downtime. The second use case that LDR is really helpful for is, again, around workload isolation and data migration. You'll see here that I have two clusters. I have a hot cluster, which is serving my production traffic, and I have a cold cluster, which is basically serving my lower tier, less critical workloads. Using LDR, I'm replicating real production data from the hot cluster to the cold cluster. But because with LDR, both clusters can receive application traffic reads and writes, you'll see here that I also have support tables. I'm running other jobs on my cold cluster. I can run my backups. I can run my CDC queries. And I can do all of this without compromising on the resources that I've put aside for my production cluster. And so that's where LDR gives you a lot of flexibility in terms of picking and choosing which tables you want to be replicating across CockroachDB clusters. So, in summary, I hope that you'll see that these tools are both extremely powerful when it comes to 2DC resiliency, when it comes to workload isolation, when it comes to data migration. And there's different trade-offs and benefits. And so we put together this table which highlights some of the similarities and differences between PCR and LDR, to recap. So PCR is unidirectional replication. It replicates at the cluster level, while LDR is bidirectional replication and replicates table subsets of a cluster. Both of these tools are really useful for surviving 2DC region outages, for surviving cluster control plane outages, for allowing for data migration between clusters. And what's really exciting about both tools is they're actually built onto the same infrastructure within the CockroachDB binary. This means that all you have to do to start these streams is just use a SQL statement in the database. That also means that we've been able to integrate it into our jobs infrastructure and integrate it into admission control to make sure that we can protect foreground workloads and run this replication in the background. So in summary, I hope that this has given you something to chew on. We are really excited about all of these tools. We're continuing to invest in these tools to make our customers as successful as they can be on CockroachDB,